There is a large debate on whether or not public safety and commercial services, let's put Wi-Fi away for a second, should be on the same DAS. I don't advocate either way. The bottom line is that we as an industry have to understand that 700 meg public safety, their downlink is right next to Verizon's uplink, the C-block uplink. And regardless of whether or not these are converged on a single system or not, that those two operations have to be taken into account, and antenna separation and or proper filtering are going to be necessary for them to coexist. Right now, I think there's a thought in the industry that by using separate layers, you get rid of the interference problems. That's simply not true. So I think from a practical perspective, a single system typically lends to a single engineer, and that is looking at the whole picture. And typically a layered approach may have two different companies, and you end up with interference problems, and typically the carriers point at the public safety guys point at the carriers. I think the best solution is to have good engineers that understand what they're doing designing the system, and that's going to be what's going to have to happen. I don't think that the manufacturers at this point really want to put the filtering in the cabinets that is necessary to support these operations where you have both services in the same buildings. And primarily, we see the problems between the 700 LTE being interfered with by public safety, 700, the narrowband services, and then again, as we have NIPS pack moving down from the top end of the 800 meg band, 851 to 854 now, we're starting to see issues with some problems interfering with the uplink of the 800 meg cellular services in building systems.
So you mentioned good engineering, so you got a good engineer next to you. But Rob, do you have an opinion on this?
Why, yes, I do, John. It's funny that you say that. We actually have a spec out on the street for a client for a luxury residential building, new construction in Washington, D.C., that, and the ordinance there do require public safety solutions for new construction. The same is true now for New York City, Boston, and various other places. So what we did to avoid the issue of having two different companies design two different systems, we actually included the spec for the two systems within the same document, specifically targeting what are the requirements of the ordinance with respect to public safety, for example. So we look at it from the standpoint of A, the venue, what is the venue type, and two, what are you trying to cover? So in the case of commercial cellular, our clients prefer to covering inside the units, provide maximum level of quality of experience to the subscribers with coverage within the amenity space. That being, for example, if there's a pool area, a party room, an exercise area, that's where you target coverage for commercial aspects. The same thing for Wi-Fi. On the public safety side, you have very specific areas that you require coverage. In some instances, different levels of reliability depending on the area in the building. So, for example, you have some ordinances that require to a specific level, signal level, let's say neg 95 dBm, 95% of the accessible space. However, in critical areas, you require not only the signal level coverage, but also a higher level of reliability. In some cases, I've seen up to 99% level of reliability, and that includes in stairwells, mechanical rooms, water pump rooms. So you have this disparate design requirements that in many instances will push the engineer to considering a two-layered approach, perhaps with a common head end. Okay, but for one possibility would be to treat the public safety layer, for example, as a separate zone or separate sector that's being fed off the common head end. That's one way to manage the two different design targets. With respect to Wi-Fi, we have seen interest on behalf of our clients to have perhaps using an integrated approach that would provide commercial cellular and Wi-Fi. Those solutions typically fall into the fiber to the antenna type technologies. and there's several manufacturers that provide those solutions. Our clients tend to shy away from those types of solutions, primarily because it requires interruption whenever there is a maintenance scenario to take place. Because now in the fiber to antenna approach is one, the antenna unit itself is about 12 pounds. They don't want to see antennas hanging off the ceiling, so everything has to be above ceiling. And if it does require maintenance because all the electronics are there, then you're required to install an access panel, which in some cases in a luxury apartment doesn't look very good. So you have these requirements that battle against aesthetics as well as performance. So by looking at all those different parameters, we'll guide you into a design architecture.
So you mentioned ordinances, Rob. I'm going to shift the focus to Ahsan. Ahsan, tell me about Oakland's ordinances for in-building. What are your existing or previous ordinances, and are there any changes coming?
Yeah, so the City of Oakland actually adopted an ordinance in 2014, which is really more of the adoption of the California Fire Code passed in 2013. So in 2014, pretty much everything, what you just talked about, minus 95, dBm power level RSSI and the 95% of the coverage, and the backup power and the backup system availability. So that's the ordinance, we have adopted in 2014, January, and which pretty much is really the adoption of the California Fire Code 2013. But just going back to this whole issue from the engineering perspective, because I'm at a fairly sweet spot, I'm the customer, so I'm looking for both services. I'm looking for the public safety and from the cellular perspective. One of the challenges I have seen since, whenever the DASs or the BDA is being deployed and they work very good, they contact the city, the fire department, the IT, we go out there, we inspect the system, we check the plans. Everything works out pretty good, but what I would like to see really is more from the engineering challenge perspective and maybe for the manufacturing is to see if the technology can provide the health and the performance of the in-building coverage before even the first responders arrive at the site.
Okay, that's good. So there is perhaps some sharing of systems, but maybe not much. So what are you guys seeing out there in terms of shared systems? Is it a growing trend, or are people kind of staying away from it, wanting to put independent public safety and cellular systems?
So I guess from the City of Oakland perspective, I can talk about, we have hundreds of course, government-owned buildings. We are seeing, again, a number of different combinations. We are seeing cellular companies providing their in-building coverage systems owned by them, maintained by them. We are also seeing, I myself deployed a number of different systems, our DAS system for our public safety responders. Technology changing fairly rapidly. A lot of time people talk about the challenge. The challenge is really not so much in the technology, but the pace with the technology is changing. Just talking about LTEU and the new, the wave of these technologies. A lot of time it really becomes very hard for government agencies to be pretty much in compliance with all these different technologies. So, again, from my perspective, ideally we would like to see more of the integrated solutions where we can have, as someone was just talking about earlier, engineered by single entity and then really maintained based on service, some type of a service level agreement by a single entity.
Okay, when we're talking about sharing, you guys want to respond to that? Because I got another sharing question.
Be going down the same.
Yeah, I'm going down. So are there new technologies on the horizon that are going to make sharing easier in the future between public safety and Wi-Fi and or cellular?
There are technologies today that make it available. The unfortunate reality is that most DAS systems are designed outside of the United States. The actual hardware design was done outside of the United States, and they don't understand the dynamic that we live in the United States. There are a few vendors that have actually built equipment to operate in the United States. The biggest problem that I see is price push. You've got the carriers that want to reduce the cost of the system by 50%, and as there are folks in this room that I'm sure understand this, where do you go? You take the filters out. And then you make the filters a add-on or a change order at the end of the project. Me as an engineering on the manufacturing side, I hate that, you know, because it always flies back in the face of the engineers, and we have to fix the problem at a later date. In other words, you know, don't do it right the first time. You know, you've always got money to do it twice, but not to do it right. And this is, I think we're going to start seeing right now, judging from what's going on in the industry, I think we're going to start seeing some real heavy price push. Number one, we have small cells coming into play. The carriers would love to be able to put in a $200 or $300 fiber to the ceiling unit. And that's all well and good. However, they're never going to be able to put the filtering in necessary to keep public safety out, especially at 700 megs and at 800. Their filters will be very, very wide on the front end. And while I don't have time to really go into the type of amplifiers that are used in these DASs, they're very high gain LNAs on the front end. And if you don't protect them, they're going to be overdriven. They do have AGCs. However, when they go into AGC mode, that's a negative thing. That reduces the coverage of that particular cell. Yes, there are products available in the marketplace that will serve the need for integrated solution. They are not cheap, and I think what is ending up happening is we're starting to see a big push to go to a cheaper, you know, a less expensive product, and that's being pushed by the carriers.
Rob, you want to comment?
Yeah, so from a technology standpoint, being able to share multiple carriers with the same amplifier, sure, that's possible. But what happens as you increase more and more channels over the same amplifier? The power per carrier is reduced proportionally by 10 times the log of that. So with respect to public safety, why would one, from an initial design standpoint, compromise the performance of that portion of the system if later on additional channels are added? Sure.
There again, this public safety amplifiers are totally separate from any of the carrier amps in what I was referring to. So the amplifiers that are dedicated to public safety are dedicated to public safety. So no matter what you do on the carrier side, it's not going to affect the public safety side. Now, there's other designs, but what I was referring to is where you actually do have a dedicated public safety amplifier, dedicated carrier amplifiers per band, and there are ways to do that, but yes, I agree with you. You start, especially there are other manufacturers besides us that do build their 800 meg system covers 700, 800, and 900 on a single amplifier. So you start having to spread that out across a broader band amplifier. But yeah, I agree.
So, and the other metric is public safety systems operate sometimes 3, 4, even sometimes 10 times the amount of power in a portable radio than you would a subscriber unit. All right, so from a link budget perspective, we were talking about earlier, it stands to reason that the antenna density for a public safety system would be much, much lower to meet your coverage target requirements than you would the commercial cellular. So using a two-layered approach also provides that benefit. One, it could reduce cost if it's looked at it that way, and it was mentioned earlier about the backup power requirements. Commercial cellular, especially in a luxury residential, perhaps not so much in a casino or in a hotel, but our client's perspective in terms of what happens to the DAS system for commercial cellular inside a building if power goes out is, who cares? It's not their business. They're not the wireless carrier. But it does matter with respect to public safety. So what happens is if you apply the backup power requirements that are listed in some of these ordinances to a commercial DAS, the cost goes up astronomically, because that means that every single remote amplifier at each IDF location, you need a UPS. And you start, you're talking about some instances, we're working a 72-story building in New York and another one that's going to have over 884 condo units. That's a lot of amplifiers. So that in itself would drive the cost astronomically high.
So Rob, while you have the microphone, what does an independent consultant bring to this party? Why should anybody hire somebody like to Rob with Black & Veatch?
Thank you for the question, John. So we are often brought to the table for a couple of reasons. One, our clients, they don't necessarily have very technical engineering staff. You know, they're real estate folks. You know, they outsource the construction, the design, the architectural, and so forth. So they reach out to organizations that tend to focus to determine what are the pros and cons and what are the key salient points for to achieve a successful design. So we help them navigate through the sea of acronyms from a technology standpoint, and reduce things down to a practical level in terms of performance and what's to be expected by their customers, which is in their case is condo owners or apartment renters and so forth. So one of the things that we do is we get hired to develop very detailed specifications. We put it through a competitive bid, and our experience has been that we can reduce the price per square foot. In the case of a DAS system, because our clients tend to be are primarily real estate, they speak in terms of cost per square foot. So we reduce the cost of each of the solution providers, which in some cases we have 6, 5, 4 systems integrators, each offering different solutions. One may be Solid, one may be Corning rather, CommScope. We're seeing Ericsson popping in with small cells architecture. And we've seen through a competitive bidding process, reduce the first initial offered price by in excess of 40%, simply by having folks compete against one another. So that's another advantage. And what I think is probably the most significant one is if you have a well-defined spec, what it does is it reduces the after-the-fact change order shuffle, because things were not made clear enough in the specification. So it shifts the liability over to the systems integrator with a well-defined spec.
Ahsan, does the City of Oakland have a requirement that DAS designs be designed by say a professional engineer, or be certified by a professional engineer or degreed engineer?
So, so we are actually still in the process of developing a lot of those requirements from the building plan check and renew approval process. That's where we are seeing a lot of coordination between the fire department, buildings department, and IT, because now it's getting to the point where fairly sophisticated technical skill sets are required from information technology departments, and they're relying on a lot of folks who are part of IT or radio shops and having the FCC licenses and understand the requirements from the radios and the propagation perspective, and of course the mission critical nature of the public safety communications when it comes to the in-building coverage. So we are still in the process of developing a lot of those, updating our approval process. So it's kind of a completely new paradigm when it comes to the new buildings, and then on top of it, it's a more challenge for the existing buildings. So we're still in that whole process that, how we are really going to make this whole new ordinance effective, not only for the new buildings, but also for the existing buildings.
I was just going to ask you that. So you don't have an answer for existing right now?
No, we don't. So again, what we need to do is, so first thing what we did is we worked with our consulting company, and that's actually formerly RCC, and they established sort of like a baseline for us for the in-building coverage. So what it really tells me is that, what is my in-building coverage look like when it comes to the mission critical system. So I'm not talking about the commercial carriers. I'm talking about specifically mission critical, voice system. So we established that sort of like a footprint. It's a baseline. Now what we are doing is we are collecting information from all the different building owners about the sort of like an inventory, and our plans are to make it available on our mapping system or our GIS system, and make it available for our really for our firefighters, first responders, because this information is very critical for them.
Right, for pre-planned. So right now, the trend in Oakland is new buildings over how many stories?
I don't have the details.
Okay. So you two guys work all over the country. Are you seeing a certain region of the country that is more stringent than others in terms of applying backward, retro to older buildings, or having really very conservative signal levels and so forth?
Well, I think right now, officially the only, and I'm not even sure it's ordinance yet, is Las Vegas, where they're going back and asking for retrofit. I don't know if there's any other ordinance out there. One of the big things we do see, and I get involved with this from the manufacturing standpoint, is ordinances are all over the place. The problem with, say, NFPA 72, and I've discussed this with Bernie about 4 years ago. If you sit in this room and you took a spectrum analyzer and looked at the baseline noise floor in this room at 150 megahertz, it would probably be right in the neighborhood of a neg 100 dBm. And we have a specification that calls for neg 95 dBm signal strength. The problem is that's 5 dB above the average noise floor in this building. It's not going to be effective. So the reality is that we saw this process that occurred in NFPA to get an ordinance, but it was built around the thought that everybody ran 800 megs. And that was what it was designed around. So I think what's going to end up happening is you're going to have to be an evolution where the cities sit down and look at or the counties look at their own particular systems and have to come up with specifications as far as signal levels go. And I would think that, we're going to see some changes at, maybe not at 150. I mean, there's a big argument. The city of Santa Rosa used to have a neg 85 dBm requirement for their VHF system, and one of the integrators pushed back because they didn't read it. And then when they tried to enforce it, it was, well, how come NFPA says this? You can't do that. And so they've actually got a couple systems in that city that don't work, essentially, because the noise floor is higher than the required signal levels. I think there needs to be a more unified, more unified building, the actual building of the system, and then so that all cities are trying to get approximately the same build quality, and then each city has to really outline their radio system. And I can go into a lot of details. I get called out on interference problems. I've had, in the last 11 months, I've had 12 incidents, 4 of them invited by the FCC, that were, interference problems. Several of them right here. One of them, Kaiser in Oakland, was taken. The integrator called me after the fact, said we had to turn the system off. Can you come find out why? And San Jose, the same type of thing. We get into these situations where I don't know if it's lack of understanding by the integrator, which I think that's part of it, but also it's very unclear as to what really needs to be done. And I think that the clarifying what has to happen for each city and them having a good understanding as well as the integrators will serve to make it easier for us to do that, or having a spec written. The problem is that right now a lot of these apartment building guys are trying to do it as cheap as they possibly can, and they don't want to go out and pay to have a spec written, or they want to literally, they go to the cheapest mom and pop place they can get to put the system in it, and it creates some issues.
So Greg, I have some good news for you. First of all, NFPA 72 no longer has in-building in it. It's been transferred to NFPA 1221 as of the 2016 edition. I think they can hear me. I personally worked on this for 3 years because what was in this standard, without going to a lot of detail, was old stuff that was BDA centric. It was 800 megahertz centric. So the 2016 spec for NFPA 1221 has in section 9, and you can look at this online. You can't cut and paste it, but you can buy it. Basically, first of all, we got away from dBm. We thought that was a mistake. because we wanted to be both analog and digital. We got into DAQ, which is delivered audio quality. We defined that. And we talked about how long battery power should be and so forth and so on. 1272 has also come out with their standard, revised standard in this year, 2016. They should both be out now. And they supposedly have taken all this stuff out and put a note to say, go to 1221. And in NFPA 1, we took all the testing stuff that Jack Daniels had put in there years ago, and we put that in the appendix area, the annex area rather, of 1221. So we made a change that I think is beneficial and takes the ambiguity out of it. Now the other problem is, as Ahsan pointed out, there's two standards bodies. There's the Western Fire Chiefs and there's the NFPA. So I have been in contact through the Safer Building Coalition with the Western Fire Chiefs. They had a meeting a few weeks ago. I could not attend it, unfortunately. And they are trying to merge, in a sense, the two standards so that regardless of which one you adhere to, you're going to have essentially the same specs. I don't know where we are on that. I was supposed to get a report. But we're working towards the end that there's basically one set of technical specs, and they pretty much agree, and they reduce the ambiguity and make it a lot easier to do testing. Okay, so the large venues, the big sports stadiums, are largely built out, and the carriers tended to pay for that. We all know that. But the middle market of middle-sized buildings is a big question mark. Who's going to pay for that? What's the economic model? The carriers don't really want to fork the money over because there's a lot more of those places. And the revenue return is much longer payback. There's a certain uncertainty to it. Of course, the carriers in general don't like to combine, but sometimes they will. The building owners of middle-sized buildings, mid-market buildings, are not sure they want to put the money into it. There's certainly the possibility for some kind of leased model where an entity goes into business and basically goes into those properties and says, I will provide that service for you, and then negotiates nationwide attractive terms with the vendors and the engineers and what have you. So the question is, what do you guys see as the right economic model for the mid-market buildings? Because right now, every forum I've been to, people have said, we don't know. Rob, you want to start that? Easy question.
I'll take a shot at it. All right, so I do agree with you. The DAS model, I'll start off with the large building scenario. It just doesn't work from a business standpoint. Number one, it's only considered to be as a value add for the resident of a building. Okay, throw some numbers out. If a building owner is going to invest in a traditional commercial DAS where the signal source is brought into the building, that is base stations, now you're talking about a potential of $225,000 in excess per wireless carrier connection signal. Okay.
That's a connection fee?
That's a connection fee. So it's, yeah. Okay. So $250,000 just to get the signal in the building. Never mind the cost of the DAS. So from an economic model perspective, you can't look at it that way. All right. For the middle market standpoint, there is a possibility from an outsourcing standpoint. Why? There are solutions that, and it's not necessarily true for every city, but using an off-air solution, for example, may provide a much lower cost implementation of the DAS. So for that, it creates an opportunity for third-party providers that will come in, install the system using an off-air solution to distribute the signal to achieve one target, and that is to provide cellular voice communications inside the building, not necessarily for optimizing for highest data rate and throughput so you could look at your Netflix on your cell phone. That's not the target. As a matter of fact, those kinds of KPIs are typically not included in those types of solutions. So there's an opportunity there. We've seen that in 3 years ago, for example, I was at a Northeast DAS conference where every single major cellular carrier said absolutely no to an off-air solution. Why? Because it was going to cause interference to their cell sites and completely uncontrolled. Now, are there rogue users out there that go in and pop up their own amplifiers just to get signal in the building? Absolutely. Okay, but they cause havoc. Now, the FCC went ahead and implemented back in the early last year very draconian fees for someone that violates that law to the tune of $100,000 per violation. So, but we've seen a shift. Because in the case of AT&T, with their budgets and investing, the acquisition of a DirecTV and acquisition of a cellular carrier in Mexico, it shifted the budgets over, it pushed it out to several years. So to get that connection fee that a building owner was willing to pay $250,000 for was being pushed out 2 years. So now they made an investment for a DAS system, just for the DAS system, let's say anywhere from another $250,000 to $500,000, if not $750,000, you have to wait 2 years to get your signal. Okay, so they went ahead and complained to the AT&Ts, and they went ahead and started to shift their tune as far as letting an off-air signal be the signal source, perhaps only on a temporary basis, but at least it's there. So it is possible, and I've seen it happen in New York. Certainly in the middle tier cities throughout the country, the capability of introducing an off-air signal to provide coverage inside the building is more plausible. So it does provide an opportunity for third parties.
Either of you guys want to comment? Yeah.
I was just going to say, I think the 3PO model is what's going to happen on a lot of these DASs, where you're going to have, well, I can already speak for one of the tower companies that we probably have all worked with for 20 years that is going to be doing a bunch of malls here out on the West Coast, and it's all a lease model. Their thought process is that they're going to meet the public safety requirement in those buildings, but they're in the door, so that when the cellular carrier comes, they sign a deal with the facility that gives them the first crack at the cell carrier. So then when the cell carriers want to come in, they augment the system to be able to handle the cell carrier. But because they're in the door and they work in, I guess, a reasonable lease for the venue owner so that they can meet their requirement for the fire code, and they're already in the door, and then have the ability then when the carriers come along, if they ever do come along, to be able to generate revenue from the carriers.
That's great. So fast forward 3 years. It's 3 years from now. What does the middle market look like? What does the middle market DAS market look like?
Take a shot.
I don't know that I know. If I knew, I wouldn't be here.
Well, I can tell you what I hope it doesn't become, and some folks in the audience may maybe want to punch me outside, but from what we hear from some of our clients is that they really would like to see voice over Wi-Fi take off as a preferred technology. All right. So we see that as a direct threat to DAS, at least in the residential space. In the multiple dwelling building category, smaller hotels, I know they're looking at it seriously, voice over Wi-Fi, especially now that AT&T just announced a service. I had the little icon pop up on my phone, so of course I had to play with it, and I was not impressed. But nevertheless, it's a solution. Now, what's happening with respect to unlicensed LTE? What is that going to occur from a capacity standpoint on the Wi-Fi side? It's all up in the air. The clients that we're working with at the moment are so risk averse. They want to prepare for every eventuality. So they're putting in fiber to each apartment. They're putting in helix cable with passive antennas buried on top of the ceilings in the event that they're looking out from a 10-year perspective. If things were to change, so initially they may say, we'll cable the entire building to be prepared for any eventuality. We can start off perhaps if voice over Wi-Fi starts to take off as a viable technology from a quality perspective, we'll start out with that. And if a few years later the technology further changes and the carrier said, we're not going to